Alright, so this is our Honors Chemistry lesson video for section 11.3, and this is part 2. So in part 1, we learned how to write complete ionic equations, and so now we're going to focus on net ionic equations. So a net ionic equation shows only those particles involved in the reaction. The spectator ions have been removed. So if you watched the previous video, this was the last complete ionic equation that we wrote together. This was the last one we did. And so the way you tell which ones are spectator ions is they are ions on both sides of the yield sign. So like for example, see how 3 Na positive aqueous on the reactant side, and then we still have 3 Na positive aqueous on the product side. So that means it didn't do anything. However, for example, 3 OH minus aqueous bonded with Fe and became a solid. So the hydroxide ion did something. And so the spectator ions in our example would be Na, like I said, NO3, because they don't do anything. Na is an ion here, it's an ion here. Nitrate is an ion here, it's an ion here. So if we remove the spectator ions, what we're left with is the net ionic equation. So once I remove all of those, I'm only left with hydroxide and iron forming iron 3 hydroxide. Okay, and so I just happen to move the iron first just because I like to put it first since it's the positive. However, you can put it in either order. And so this would be our net ionic equation. Now you don't have to sit there and write the complete ionic equation in order to get the net ionic equation. However, some of them that get a little difficult, it does help to do that. But for the easier ones, I'll show you how I do it without writing the complete first. So let's go ahead and look at one that I already did. So to write the net ionic equation, you only consider the non-aqueous substances and the ions that form them. Okay, so I can look at the reaction right here and I can see, okay, NO3 is aqueous here, it's still aqueous here. So I can see just by looking at it that nitrate didn't do anything, again in this example. I can look here and see that Bi was aqueous, but see now it bonded with sulfur and became a solid. So I can see that bismuth actually did something. But before we get into that, you got to balance your equation first. Okay, so we balance our equation. So I have 1 Bi, here I have 2, so I put a 2. Here I have 6 nitrates. Okay, nitrates NO3, but the 3 goes to it in the 2. 6 nitrates. Here, remember, this is all one thing. This is not 3 things. It's one thing. So I need a 6 here. So see, now I have 6 nitrates, 6 nitrates. All right, next I have 1 sulfur, 3 sulfur. So I need 3 here. And then last I have 6 hydrogens and 6 hydrogens. All right, so I have it balanced down here. So my next step is to figure out what are the spectator ions. So again, I can see that NO3 was aqueous here, and it's still just aqueous. I can also see that hydrogen is aqueous here, and it is still aqueous. And then finally, I can see that Bi and S were aqueous ions, but now they have bonded together to form a solid. So that is what I would pull down. Now what I want you to notice is I also pull the coefficients with them, and I had to include the charge when they are ions. Now once it bonds, you don't have to include the charges. You can if you want to, but you don't have to. Alright, so let's look at one together where I didn't pre-work it out for you. Alright, so it says write the net ionic equation for the following reaction. So the first thing I'm going to do is I'm going to balance. So I have 1 Pb, 1 Pb. I have 2 nitrates. I have 1 nitrate. Remember, this is all one thing. If it helps, circle it so you'll remember it's one thing. Okay, so I have 2 nitrates. Here I just have 1, so I'll put a 2. I have 1 sulfate, SO4. I have 1 sulfate, SO4. I have 2 hydrogens and 2 hydrogens. Alright, so let me figure out what my spectators are. Alright, so Pb was aqueous, but now it has formed a solid, so it's formed a precipitate. So Pb actually did something. Nitrate was aqueous. Nitrate is still aqueous. So I don't actually care about nitrate. Hydrogen was aqueous. Hydrogen is still aqueous. So I don't care about hydrogen. And And then sulfate was aqueous, but now it has formed a precipitate. So see, all I need to pull down is the lead, the sulfate, and the lead 2 sulfate. Alright, so I have to figure out the charge though for lead because it can have multiple charges. Nitrate is -1, but there's 2 of them, so that's -2. So lead is going to be +2 this time. So I bring down my lead, I put its charge, and I put the little aqueous. I bring down sulfate. When it is by itself as an ion, you have to put the charge. So its charge is -2, and it is aqueous, and it yields PbSO4 solid. And like I said, I don't need to write charges here because once it's bonded, you aren't required to write charges. However, if you did, it would be fine. Alright, and so that's all you have to do for net ionic. Okay, now sometimes they are a little trickier than this, especially when we get to remembering about weak versus strong acids, but we'll talk about that when we get there. Okay, so there was my answer. Alright, so maybe pause the video and try this one, and then we'll look at it together. So first step is I need to balance. So I have 3 sodium and 1 sodium, so I'll put a 3. I have 1 phosphate, PO4, 1 phosphate, PO4, 1 iron, 3 chloride, and 3 chloride. So everybody's balanced. So now let me figure out who my spectators are. So Na was aqueous, it is still aqueous, so I can get rid of Na. PO4 was aqueous, but now it's formed a precipitate, so it's a solid, so it did something. Fe was aqueous, but now it has formed a solid, so it did something. Cl was aqueous, and it is still aqueous, so I can get rid of Cl. So all I'm interested in is the phosphate, the iron, and the iron 3 phosphate. Okay, so I just pull down what I have left. So I have phosphate, which is PO4, but when it's an ion by itself, of course, it has a -3 charge. Iron can have multiple charges, so you have to look at what it was bonded to. So Fe is bonded to Cl. Cl is -1, but there were 3 of them, so that's like -3. So iron had to be +3 this time. So I'll put its charge and put aqueous, and then the solid, I just leave it alone. Alright, so remember, the spectators will be aqueous ions on both sides of the reaction. That's how you know it's a spectator. Okay, and I kind of focused on solids for right now, but I'll show you some examples where it doesn't just have to be a solid. It can be solid, liquid, gas. As long as it's reacting, then it's not a spectator. So hopefully you got that one right. Alright, so the last thing I'm going to show you is, like I said, an example where it's not necessarily a solid. And so these 2 examples, you're just going to have to kind of memorize them. Alright, so the sulfide ion and the carbonate ion will react with acids to form gases. So if you look here, if we have HCl and Na2S, remember it's going to be a double displacement. So Na and H are going to swap places. So now Na will be with Cl, which that's what it looks like right here. And now H will be with S. And of course, because S is -2 and H is +1, that's why I need the 2. But you just need to remember when this substance forms, it is a gas. Okay, in the next lesson video, I'm going to show you how you know if something is solid or aqueous using solubility rules. But these 2 gas examples, you just have to memorize. So if you have a reaction and you form H2S, I need you to know that's going to be a gas. So H and S would not be spectators. However, Na and Cl would be. Alright, the other one is the carbonate ion. So when you have a double displacement reaction like this, where Na and H are going to swap places, H is going to bond with HCO3, and so you end up forming this H2CO3 aqueous. However, this is the part that I just need you to kind of memorize. What's going to happen is H2CO3 aqueous naturally turns into liquid water and carbon dioxide gas. Okay, so all I did was down here, I just replaced that with the liquid water and carbon dioxide gas. So if I was trying to write the net ionic equation, if I had this top part of the reaction, since everything appears to be aqueous, it makes it seem like there is no net ionic equation. So if everything's aqueous on both sides, there's no reaction. There's no net ionic equation you can write. So like I said, it appears that there isn't one until you have to remember that this actually became liquid water and gaseous carbon dioxide. Okay, so once you see it down here, you can see, oh, okay, wait a minute, everything's not aqueous. I can write a net ionic equation. Okay, so like I said, these are just two examples you just need to memorize. H2S becomes a gas, and H2CO3 will break apart into liquid water and gaseous carbon dioxide.